Hello friends, our operating system subject has Unit 5 Memory Management. Today we will see the part 4th of it. These are the course outcome and unit outcome of Unit 5 and these are the contents of Unit 5. In today's lecture we will cover the topic page replacement algorithms. Now, what is the page replacement? Initially, according to the address generated by the processor, the page is searched in either page table or the segment table. And if the page is found, according to that, the pointer will be set to the main memory. And if the page is not found, there is trap to the operating system. Operating system will search the page on the secondary memory. The page is available on the disk. We need to bring it into the main memory for execution. For storing the page in the main memory, we need to find free frame. And if the free frame is available, we will replace our required data into it. But if the free frame is not available in the main memory, the system needs to find such a frame, that is the victim frame, which is not required further. The frame data must be replaced by the required data. So, the system should select the victim frame in such a way that minimum page replacements will be required to perform. For that, there is need of page replacement algorithm. There are 3 page replacement algorithms: first in, first out, optimal page replacement, and least recently used page replacement algorithm. We will see first the first in, first out page replacement algorithm. In short, it is also called as FIFO. FIFO is the simplest page replacement algorithm. The FIFO page replacement algorithm associates the time when that page was brought into the memory. When a page needs to replace, the oldest page is selected for the replacement. It can be implemented using FIFO queue. We can replace the page at the head of the queue, and when the page is brought into memory, we insert it at the tail of the queue. Now, this is the reference string which is provided to us, and we have to apply our first in, first out page replacement algorithm for this reference string. This is the reference string of the page numbers which are required for the execution. The sequence, the pages will be required in this sequence for the execution. Means first page number 7 is required. After that 0, after that 1, 2, 0, 3, 0, 4. In this way the pages will be required for the execution. And this the frame size is 3, means at most we can store 3 pages in the main memory. So initially there will not be any page into the main memory, so it will be blank. After that, the first page required by the processor is the 7. So it will be stored in the first frame of the main memory. The second page required by the processor is 0. So it will be stored into the second frame. And third page is required by the processor is 1, which is not there in the main memory. So it will be stored in the third free frame. Now, initially as there were no pages in the main memory, so for every requirement of the pages generated by our processor, there is a page fault. Means as we are storing 7, so 7 is not there in the main memory, so there is a page fault. That page will be searched into the disk and will be brought into the first free frame of the main memory. Now the second page request is 0. Again it is not there in the main memory, so again page fault is there, so that 0th page will be searched in the disk and will be brought into the main memory. Again the third page is searched, that is what first page, which is searched in the main memory. It is not available in the main memory, so it is searched onto the secondary, and it is brought into the third free frame. Now all the three frames are occupied. Now the fourth page required is 2. Now we need to select a frame whose page will never be required, okay, immediately. So for that we will select the page which is enter first into the first system, okay, that is which is enter first into the main memory. So out of 701, the page 7 is enter first into the main memory, so that will be selected for the replacement. So we are putting 2 at the location of the 7. So the need of the page, that is second page, is satisfied. Now there is request for page 0, which is already there in the main memory, so there is no page fault for the 0. Now the next page required is 3. So as the 3 is not there in the main memory, again there will be page fault, so the third page will be searched into the secondary, and all the 3 frames are occupied, so we need to select the victim frame. So out of these 201, the oldest page is the 0th page, so 0 need to be replaced first, okay. So 3 will be written at the frame where the 0th page was written. So in this way we have put the third page into the 0th location. Now the next page required is 0th page. Now from this 2, 3, 1, the oldest page is 1, so that will be required to be replaced. So the victim page is 1, so we will place our 0 at the 1 page location. Now the next page required is 4, which is not in the main memory, so again we will need to select the victim frame. So our victim frame will be the oldest page, that is what 2, okay. So it will be selected for the replacement, so 4 will be written at its location. Now the next requirement is 2. So the 2 again there is not in the main memory, so we will select the victim frame 3 for the replacement. So 2 will be stored at the location of 3. Now the next page required is 3. Now out of these 4 to 0, the oldest page is 0, so it will be selected as a victim frame and 3 will be stored at its location. Now the next page required is 0, which is not in the main memory, so again we will select the victim frame which is enter first, the page which is enter first in the frame, okay. So the fourth page is the oldest one, so it will be selected for the replacement. So 0 will be placed at the fourth page location. After that 3 is there in the main memory, so there is no page fault for 3. 2 is there in the main memory, so there is no page fault for the 2. Now 1 is not there in the main memory, so we will select the victim frame. So out of these 3, 0, 2, 3, the oldest page is 2, so it will be selected for the replacement. So we will put 1 at the location of 2. Now the next page required is 2. Again it is not in the main memory, so we will select the victim frame which is the oldest one. So 3 is not there in the main 3 is the oldest one, so it is the victim frame, so we will put our 2 at its location. Now the next required page is 0, so it is there in the main memory, so there is no page fault. Again 1, it is there in the main memory, so no page fault. Now 7 out of these 3 we need to select the victim frame. So the victim frame is holding the page 0. So 7 will be placed at a 0th location. After that 0, so 0 is not there in the main memory. So we will need to search the victim frame. Now the victim frame is 1. We will place our 0th page at the location of page 1. Now the next required page is 1. So again the victim frame is 2. So we will place our first page at the location of second page. In this way, we will get the total page fault 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So total page faults are 15. So this is very simple method and this can be implemented practically, but the number of the page fault is more as compared to the other two algorithm. So we will see the next page replacement algorithm, that is optimal page replacement. The optimal page replacement has the lowest page fault rate of all three algorithms. This algorithm guarantees the lowest possible page fault rate for a fixed number of frames. Unfortunately, this algorithm is difficult to implement because it requires the future knowledge. Now let us see the same example for the optimal page replacement. Now this is the reference string which is required by the processor. Okay. Now the first page required by the CPU is the 7th. So initially there will not be any page in the main memory. So again the frame size is 3. So first for the 7 there is page fault as the page is not in the main memory. So the 7 will be stored at the first free frame. After that 0 is not there in the main memory. So again page fault for the 0. So 0 page will be stored at the second free frame. Again the next page is 1. So 1 is not there in the main memory. So again page fault for page 1. So it will be stored at the third free frame. Now the next page required is 2. Now out of these three, 7, 0, 1, we need to select a victim frame in such a way that the page which is not required immediately, means the page which is required us far in future. So out of these 7, 0, 1, so if we are at 2 second location, 0 we will immediately required, 1 we will require here, and 7 we will required at this location. So 7 is far away, which is required in future. So we will select 7 for the replacement. So page 2 is placed at the page 7th location. Now the next required page is 0. So 0 is there in the main memory, so no page fault. The next page required is 3. So these 3 again we will select out of these 3 which is to be a victim frame. So 2 from this third page, 2 we will require at this location, 0 we will require here, and 1 is here. So the 1 is the farthest which will required in future, so that will be selected for the replacement. So we will place 3 at its location. So the next required page is 0 is there, so there is no page fault. Now the next page is required is 4. So again we will check for these 3 which is required in future. Okay, so for 2 is we will require immediately. After that 0 we will require here, and 3 we will require here. So the 0th frame we will require farthest one in future. So we will select the 0 for the replacement. So we will place page 4 at its location. Now the page 2 which is there in the main memory, page 3 which is there in the main memory, so there is no page fault. Next page required is 0. 0 is not there in the main memory, so page fault is there for 0th page. Now The out of these three, which is not required, or which is required farthest in future, that we will check. Now from 0th page, 2 we will require here, and 3 which is immediately required after 0, and 4 there is no fourth frame in future, so we will replace it by 0. So we will put 0th page at 4th page location. Now 3 it is there in main memory, 2 there it is there in main memory, so there is no page fault. Now the next page required is 1. So for 1 we will check for these 3 pages. 1 2 which is required immediately after 1, so we will not select it as a victim frame. Now 0 is also required, 3 is not required in future, so we will select it as a victim frame, so 1 will be placed at its location. So the next page required is 2, which is there in the main memory, so no page fault. 0 is there in the main memory, no page fault. So 1 is there in the main memory, so no page fault. Now we need to place 7. Now out of these 3, 0 we will immediately required, 1 is also required, and 2 is not required in future, so 7 will replace the 2 page. Okay, so the victim frame is 2, so here we have put the 7th page. So in this way the total number of page fault is 1 2 3 4 5 6 7 8 9. So 9 page faults are there in optimal page replacement. Now we will see the next one, that is the least recently used page replacement algorithm. Both FIFO and optimal page replacement algorithm has drawback. Like the FIFO requires more page fault and optimal required future knowledge, which is not possible practically. So out of that, the least recently is used which is solving the problem of both of these page replacement algorithm. If we use the recent past as an approximation of near future, then we can replace the page that has not been used for the longest period of time. Means instead of checking the future page request, we will check the past page request. So, and considering that the past will appear in future, we will use that knowledge, past knowledge, for the future frame. So it may be helpful. So same approach is used in least recently used algorithm. When the page must be replaced, the least recently used will select the page that has not been used for the longest period of time. So let us see this least recently used algorithm for the same reference string. Now again initially there will not be any frame, so we will put our first page, that is 7th page, in the first free frame. After that 0th page at the second free frame and 1 page at the third free frame. So for these 3 pages there will be 3 page fault. Now we will need to put the page 2. So for that we will see the past frame uses. So we will check the page which is farthest used in the past. So the 7th page which is farthest used in the past, so it will be selected for the replacement. So and page 2 is put at its location. Now the 0 is there in the main memory, so no page fault. 3 is not there in the main memory, so page fault is there, and we will require to select the page which is farthest used, which is not used in near past. Okay, so before 3 we have used 0, 2 and 1 which is the page which is farthest used in the past, so it will be selected for the replacement. So page 3 is put at the location of 1. After that 0 is there in the main memory, so no page fault. Now for 4 we need to search the page which is oldest one used in the past. So for from the 4, 0 is just before use, 3 before that use, and 2 which is used at a very long time. Okay, so it will be selected for the replacement. So 4 page is placed at the page 2 location. Now the next page required is 2. So for the same we will check for these 3. So 4th page just we have used, and 0th we have used before that, and 3 is the oldest one. So we will select that 3 for the replacement and put 2 at its location. Now again 3 is required. So again 2 is immediately before use, before that 4 is used, and before that the 0 is used. So we will select the 0 for the replacement. So 0 is replaced by the page 3. Now again next we will require 0. Again we will check the page which is the farthest use. So it is 4. So we will select it for the replacement. So we will put 0 at the victim frame 4. Now the next page required is 3. 3 is there, 2 is there, 1 for 1. Out of these 3, 0 is the oldest one that we have used. So it will be selected as a victim frame, and we will put the 1 page at its location. Now 2 is there, so no page fault. 0 is not there in the memory. So there is page fault for 0. Now from this 2, 1, 3, the third page is the farthest one that we have used. So it will be selected for the replacement. Now the next page required is 1. It is there in the main memory. Now 7 is not there in the main memory. So for 7, out of these 3, 2 page is the oldest one that is selected for the replacement, and 7 page is put at that location. Now 0 is there, 1 is there in the main memory, so no page fault for that. So total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 page fault for the least recently used page replacement algorithm. This is intermediate between the page faults of the FIFO where there it was 15 and the optimal where it was 9. So the least recently used page replacement algorithm is used in many of the system. Thank you.